some new material, but it's stuff I will not be testing you over, and that's basically X-repping and how we do it. Keep in mind this is backed up, I think, with chapter 30, the X-rep chapter. So if you have any questions on that, that should be your first alternative. Second would be me or help. Actually, text, help, me. It's probably the best method you can get used to doing, because that will transition into the workforce in a great way. All right, first thing I would like to talk about is this guy. So, this is an assignment I've never given out before. So there are quite a few options with this, but in essence, as we talk about the geometry of this and how we're going to display it, it depends on how you set it up. In my mind, this is probably my front view right here. Okay. And then what that does, that makes, in essence, I'm going to have an inclined plane. And there's quite a bit of complex geometry with that inclined plane in that we have a slot. But which one do we choose? I think the majority of the object is this thing. Here's the base. That's probably where it's sitting down, being bolted in. So that's why I would choose it either that or this way. One of the two is my front view. Be that as it may, you're going to get an inclined plane. Now, there's a few discrepancies first with the instructions. And I'm going to use this as a teaching moment because I just basically slapped this thing together in 5 minutes and threw it out there. But does this happen in the workforce where you have conflicting instructions on what your tasks are? Most of you are fairly younger. Is there any discrepancies that your parents gave you when you were doing chores? What did you do to clarify those? You asked, right? So you had discussions on it. You know, hey, I'm unclear on this. You want me to use this power saw? I don't even know how to plug it in. That'd be a good thing to ask. But yeah, so we need to have these discussions. Now, where are the discrepancies on this? First off, the instructions of the problem versus the instructions on your sheet. Okay. So in essence, on this, they give you fractional format, but they ask you to switch it to decimal, and that's all right over here. And how many decimal places do they ask you to go to?
3.
Go to 3. Okay. Except for one area. And the slot goes 4. Right? And they want you to use limit dimensioning. And then what do my instructions say?
2.
Decimals to CSI standard, which is 2.
Decimal to CSI standards, which for us is 0.02. What are we going to do?
You're the teacher, you wrote this so it goes with yours.
We get clarification.
Yeah.
Right? So we need a decision to make. Do we stick with 4 decimal places? Because if we go CSI standards and they're telling us to go 3, so I'd have to switch all these to 3. So like 7/8 would go what? 0.875, right? So it wouldn't be 0.88, and it wouldn't be the 4. Now we do have one with 4, so therefore we're going to have something that has to say UOS, because there's going to be discrepancies in your notes also with the way you dimension. Remember, typically we would say all dimensions plus or minus 0.000 or tolerancing to 3 places. And then you would always put UOS if you did anything different on the drawing. Because you're giving them a note saying, hey, go this, but I put UOS on there. There's something else out there that switches. Be aware of it. Okay. That's what that UOS is meant for. Okay. Now, let's go ahead and clarify. Do we need to go 3 decimal places for this? Do we need to go 4 for the slot? Well, we don't have the capabilities of going that deep, so please go 2 decimal places. So I'm clarifying that now. Go 2. Second is, how do we want to display this? Because really, when you look at this, we don't get a good look at many of the items. I kind of sketched the multi-view. Okay, so let's just kind of, and again, I kind of did this fairly quickly, so I'm not promising that it is all correct. It's fairly close, I imagine. It's a good place to start. So in essence, when I'm looking at this, two items that really kind of bother me with this. Number one is the inclined plane. We need to show it true size and shape in some form or fashion. Number two is we don't ever really get a good look at the thickness of this material. This is my best look at the thickness of material throughout the whole thing. This is not a good geometric look of the base. Okay? I don't get a good geometric look here because I've got that tied into it. So that's one problem with it. The other problem is, how many views do we really need? Okay, and what do we need them for? Lisa's saying we need 3 views. But let's look at the geometry. This base plate, got 2 holes in it, circular view, rectangular view. Okay. Height, width, depth. I would say though that base plate is done here. This upper plate here is fairly straightforward. It's just a big blank surface. The only thing that's different is we got this nose coming into it, or I guess they call it a rib. So this is described by here and here. This piece right here is not described by here and here. Okay, I gotta have this view for that. The auxiliary or inclined plane is totally described by this view. So in essence, really, I kind of look at it as from here back and here back. Those are both foreshortened views. Certainly we need to tie one of them together so we show how it's done, but neither one of those has really given us anything other than how the things are tied together. So I guess in my mind, I would probably be looking at drawing this one in its entirety or this one in its entirety, either or, and then I would do a partial on the other one. So I'd maybe come in here and do something like that and do a partial view. Just so I don't confuse the issue. Now, where do I handle the thickness of these plates? Back to the original. I really think the only good view you got of it's right here. The only good contour view. So in essence, I would probably be looking at throwing it right here somewhere and take advantage of this node. We really haven't had a chance to use it yet. Okay, but here's a good chance to use it. Okay, 0.38 TYP. This is a perfect illustration of what we use typical for. So now, whenever they see a plate, and I have to make sure I leave it undimensioned in all other views, then it should be 0.38. I do have another option. Can I put it in my general notes and saying all plates constructed from 3/8 material, and then not dimension any of them? Yeah, I can do something like that too. The thing is, here we've got a difficult situation and we can't do it really with pictures. So we want to make sure we're joining our text with it as long as it is clear. We want to try and clarify that as much as possible. So that's an instance I would do with that. Now, the reason I bring that out is because I've seen a couple of these and I don't know if they're right or wrong in that individuals have taken this, pulled it out, and done a 2 or 3 view drawing of it. That's certainly acceptable. Certainly acceptable. But you're going another step of confusion in that you're removing the rotation off of it. So you need to be doing some clarification on it. So you're either doing a removed view where you are delineating it, and I'll steal how one of the people did it. They went in and they used the wrong line type, but we would use a phantom line, something like this. We would then interject a letter in there saying that it's a removed view, then pull it over. This needs to have a title that says View A. Okay. And then we're showing that in a different orientation. That's certainly something we do. I think it would be my second choice if I couldn't make this work first. Okay. Yes?
I know this is kind of off topic, but how do typical and tolerance go in hand? Because if you have a tolerance on it and it's typically that, it already has a, you know what I mean?
Typical is a size dimension. tolerance is the amount of slop any dimension can get. You're confusing the two. They aren't related at all.
No, but if you have like a tolerance on like all dimensions, say that, and then you have a typical, the typical would be 0.38, and you just go,
Are you saying if I'm using bilateral or limit dimensioning with it?
Yeah, yeah.
Okay, then it would be a comma, typical. But you still dimension it in full. So if you were doing something like, the information they gave was something like, what was it, it was on the slot. But let's say it's here, let's say you went 0.3880 and you went 0.3775. Okay, so I was using limit dimensioning. I would still have a comma and then typical. And that's just saying every time you build one of these, you're gonna, that's the dimension you're gonna use for every one of them.
okay.
Do you put the comma in the normal, the short way, 0.38 PYP? Or is it 0.38 comma?
No, because remember, there's an extension, dimension line here. At center, when we do limit dimensioning, we bring them up and down, where my upper limit is on the top, my lower limit's on the bottom. By the way, it's wrong in the text. And then I would center the typical on my dimension line. Yeah, so there's another dimension line right here.
Okay.
On that instance, I'd be pulling it out right over here, because I can't get that in that distance. Now there's another thing. So you go ahead and produce this. Is this thing getting in the way of this? Your spacing is going to be something you're going to want to look at fairly closely. Now the nice part about doing this on CAD is you can move things around, but keep in mind, if you're going to pull an auxiliary view like this, it should be lined up in that fashion so that somebody can make that rotation in their mind. Okay, so you're aiding them in the rotation. So whether you put it close right here, but then you might get in some way in some dimensions here, you're going to have some choices to make. Do I pull it out and put it right out here? Here? Do I give a little more room here? You've got all those options available to you. But as it sits right now, you can kind of see, okay, I've got to locate these guys. If I choose to locate it here, well, I can't have that. So that auxiliary view needs to move in the right location. Or a clear location. Are there any other thoughts? I think a good portion of you are on this or have finished it. I had a question this morning then.
I don't know, I was just, is there any value in the dimension, the width? It's not the full width there, because that's for sure, even that width there, because you have to get the width there, so you have to give the width down here.
I give the width here.
But what about the full base?
Yeah, I could pull that up right here.
No, excuse me, the depth. Excuse me, how many depth?
Yeah. If I'm going to leave this one intact, I
Just
would
do it
put my
there.
depth up here.
So don't pull it off of there.
That's correct. Now, I do need some depth here because this is my best look at it.
Yeah.
So this one would still probably have some depth, like that one.
Okay, that's what I was saying.
And then I definitely would probably have this height. And it's related with the base, so I would do that one there. Because that's my contour look. Remember, the contour is more important than associative. It's more important than grouping. But that's the only reason we're doing this view is this piece.
Mhm.
Based on the orientation I started with. Certainly, if you start with a different front view, your options change. I had another question on this, and this happens quite frequently with large fillets and rounds and cylinders. When I pull a dimension off of one of those, and I'll use this as an example, because I'm gonna rotate all my dimensions to this orientation, right? So this guy's gonna look something like this. right here. My dimensions would then be pulled on this orientation. Now, when I come off of here, and let's say I pull that dimension, when I get these large ones, it's real tricky on whether you get a gap there or not. And we need a 16th gap. Now, in essence, you can't see it on a computer screen unless you're using the line weight display option. Some of you use that, right? Where it estimates the line weight and shows you these real thick lines versus thin lines. Most people don't, I don't. Because it just, for me, it clutters my screen up and I can't see my snaps as well. And that's my main reason for not using that line weight display option. But in essence, when you print it, you got to remember that this is a really kind of a fairly thick line, right? It's an OBJ. And you're looking at it on the computer screen and there's a gap right there, and then you print it and the thing looks like this. Because that thick line covers up that little 16th gap right there. Many times you don't know if this is going to occur until you print, but folks, look for this. Okay, when you print it and you're redlining yourself or you're getting a pier and you're redlining theirs, look for these things on these circular surfaces because it happens quite frequently. The best way I would tell you to solve it is you can't change dim EXE. Okay? If you change one of them, you change both of them. So if I said, okay, I want to take this, which is set to a 16th, it's dim EXO actually, and I change this to an 8 to give a little bit more room here to account for that curvature, it's going to change that one too. Okay? You can't change both of them. It's one variable for both of them. Okay? So when you get this, in essence, the only option you have is to move your grips. Okay, that's it. And that kind of works the best. I did kind of throw one out here because I did want to display it. I threw it on my screen, so let me switch to this real quick. So here's a case where I've got one, and right, see on the computer it looks like that. I'll tell you right now, when I print that, I will not see that gap. Okay, I will not. So the best way to handle it is just grab your dimension. You do have grips right here. Now I'm just going to grab that grip and I'm going to come back and it will, and I just estimate where it's at. Let your puller kick in and I move that grip out. Now there's a couple things wrong with that. It's no longer associative because I pulled it off the geometry. So now if I change my circle, that's not going with it. So you've got some other things to watch out for. The thing I wouldn't do, because that's the least of all your evils, is I wouldn't explode it and then trim it back. Because I still want it working with the Cartesian grid, and that dimension that's going with that will not work with it if I explode it. So that's really just kind of a quick and dirty way. I do not know of another way to really do that. Just grab those grips, pull them out, and then you might have to print it.
Your preview shows.
Yeah, print preview will help you, but you've probably learned print preview doesn't catch everything. There's nothing, at least in my mind, that replaces that hard copy. And again, just look for these. Look for this case. It will pop up. In fact, it pops up on this one. All right, are there any more questions you can see in here? Any questions you might have? Did I clarify the instructions? We're going 2 decimal places. You can use a general tolerance plus or minus 0.02. Disregard the stuff in the text.
You can align if you use the auxiliary view, you can align our dimensions. Right?
Yeah, well, the align will work on anything that you can snap with equal extension lines. If you don't, then you got to go dim linear and rotate it. And you would put all these dimensions right here on the true size and shape view. Remember, it is a slot, so please follow the slot dimensioning techniques. Any other questions on this? Okay. The one that was before that, any questions on this one? This one was due on Friday. I think I've graded almost all these. I think I've moved everybody out of it. This one also had a pretty tricky little surface. And in essence, there's this little thing right here, right? I don't know that that one justifies an auxiliary view. It's not really a dihedral angle because it does occur on a normal plane, so you do see true size and shape of it from this view right here. So you don't need to pull an auxiliary. Whether you went to locate one side of the triangle on an angle or 2 points on the triangle is up to you. Remember, it is preferred to have the 2 points on the triangle, not 1 point in an angle. When you get these angles, let me just point this out, that are even increments of 15, like 15, 30, 45, 60, 75, 90. Those are ones, in my mind, that many times I will go a point at an angle and not worry about going 2 points. And why is that? It's simple, but also all of your cutting machinery understands that those 15 degrees are worked, and they probably have set points where you rotate to those. I mean, if you look on any cutting instrument you can buy, and it's got those, like a meter saw that can go 3 angles, a 3-axis cutter. It's got 15, 30, 45, all done. And when you rotate those things to it, you'll feel them click in. It's the same with machinery we spend much more money on than those $100 pieces of equipment. No questions here? No thoughts? All right, Friday, we brought out drawing 6. And I know the people that were here Friday, we went over a good portion of it, and I kind of need to repeat that for today. So you're welcome to draw, or if you want to hear it again, please do. I am going to go a little bit further today because I do need to show the X-roughing. So first off, when you got drawing 6, you got a whole book on the darn thing. In essence, we're going to switch to the architectural world here, but what we're really going to do is dimension something and have multiple scales on the same sheet. Now, at the end of the day, when we print a drawing, it doesn't matter what my scale is, my arrowheads are always an 1/8, no matter what the scale, right? My text that is on it is always an 1/8. My gaps are 1/16, 1/8 on extension lines. All of these criteria still need to be on a sheet regardless of the scale. Therefore, when we do multiple sheets on here, you're going to want to make sure you're paying attention to dim anno and you are calculating the DSFs for these scales. Now, we have 3 scales on here. You're going to do a floor plan that is 1/4 inch to a foot. You are going to do a wall section that is 3/4 inches to a foot. And then the last one down the bottom, you're going to do a footing section that is at 1 inch to a foot. All of these are going to print on the same sheet. Can you real quickly hit the light, please? Let me show you the finished example first. Okay, so here's what your finished, no it isn't. Here's what your finished example is going to look like. Okay, so now whether you put the floor plan on the right and you move these other details or whatever order. So here's your floor plan. Now the point I'm trying to make is that this guy is going to print at 1/4 inch to a foot. When you look at these slash marks. They need to print at an 1/8 inch. This dimension line needs to be a 1/2 inch off. This little gap right up in here needs to be a 1/16. This has to go an 1/8 pass. That's what I'm talking about, is all these standards. Now, let me kind of zoom in over here where I can see both of these at the same time. And I think right here you can, up on the 3/4. So this one's printed with a DSF of 48, 1/4 inch to a foot. This one is printed at 3/4 to a foot, my DSF is 16. But is that slash mark the same as that slash mark?
What kind of art, is it that one rotated?
No, on the print? Yeah, they need to be the same. I want all that the same. Is my text an 1/8 inch high on that view? Yes. Is my text an 1/8 inch high? Here. Yes. Everything wants to be the same. That's following our standards. That's really the point you want to pay attention to. But that's my hope, is that we can produce this drawing in its entirety where all my dimensions are good. On all 3 views, they all read the same. Now, to do this, you're going to have 3 different drawings. I'm just going to close this down. I don't really want this drawing. Did you get the drawings off of Google Classroom? There was 3 drawings on there. Okay. If you didn't get those, please download those right now.